Okay, so let's look at the same example, but this time we're going to perform a t-test for the data. We are now asked, is there evidence that the wait times for the ambulance riders is shorter than those who drive themselves? So, just like before, we have the data provided, 77 ambulance riders versus 73 self-drivers to this hospital, and then we have the wait times and standard deviations for those wait times. So first, just like always, what are we trying to do? Well, we're going to test to see if there is a difference between two means in this case. Now, how do we write that? There we go. We would like to test to see if there's a difference between mu1, the mean wait time for patients who arrive by ambulance, and mu2, the patients who arrive via themselves at the 0.05 significance level. So we've stated what we want to do. We've included the definitions for our parameters that we're testing, and we've included the significance level. The conditions are going to be just like they were for the confidence interval. So first we've got to check to see, is it random? And again, it says in the problem that it's random. Does it follow the 10% rule? Basically, yes. Again, 150 patients with a heart attack would clearly be less than 10% of all the heart attack patients that a hospital has seen. And again, both samples are over the size of 30, so the large count would apply. So, the central limit theorem would begin to apply. So, there we go. For the hypotheses, we haven't stated them yet, so I'll go ahead and write that. Actually, I should put that up here. All right, so for the alternative hypothesis, by the way, since it says is the ambulance time for the, is the wait time for the ambulance shorter than the self, that means the first mean would be smaller than the second mean, which means this value would be less than 0, correct? So, there we go. Now, to actually perform the test. So, menu statistics, perform the stat test, and again, this is a two-sample t-test. We have the stats. All right, there we go. Again, we're doing that the first mean is smaller than the second mean, and we do not know that these come from the same population. As a matter of fact, we're almost certain that they don't. We're testing to see if the difference is 0, but we know for a fact that they don't come from the same population. So we would not pool this data. And so there we go. We have all of this wonderful information. We have to scroll up a little bit to see everything we need. So there is the critical t. There is the p-value. So our test statistic is negative 2.9, and our p-value to go with it is 0.002. The difference in the sample means results in a test statistic t equals negative 2.9, which has a corresponding p-value of 0.002, suggesting that there is a 0.002 or a 0.2% chance that the difference between the two means would be as large as it is if they were in fact the same wait time. Now, for the conclusion, because I know that sounds like it's a conclusion, but really we haven't gotten to the conclusion yet. So, is this value, the p-value, less than our significance level? And the answer is yes. We chose a significance level of 0.05. We have a p-value of 0.002. So this is statistically significant, which means we will reject the null hypothesis. Now, what does that mean? Well, it means we have evidence for the alternative, and the alternative was that the difference between the two is less than 0, or that the mean wait time for the ambulance was less than the mean wait time for self-drivers. So there you go. So there's the 4-step process for a t-test. Hope this was helpful.